Hi, my name is Sumedh Barde. I am a product manager in Azure Security dealing with secrets management, key management, encryption, everything that you store at rest. Let me get started with secrets management. So let me start with the story of George. George is writing his first cloud application. It starts very simple. The cloud application is some code running in the cloud. Uses maybe Azure Storage to store some things, maybe Cosmos DB to store some things, has an API key that it uses. Maybe it has a certificate, a TLS certificate. And George, every so often, goes to a CA, gets a certificate, goes to Azure Storage, gets a connection string, takes it to the application, deploys it. Life is simple. Things keep running. Over time, this is what starts happening. The number of cloud applications starts growing. The number of dependencies starts growing, and the number of secrets that application pulls in starts growing. The number of applications itself starts growing. Now, George's company starts using SaaS applications, maybe some on-premises applications, a number of cloud applications, and you can start seeing it starts becoming a mess. What's even messier is the number of tools he uses and the number of other people who start coming into the play, trying to take secrets from the left, trying to deploy them on the right, and remembering to renew them every few months. And guess what? Very soon, George is a very sad man. Why? These things start happening. This is a real query I ran on GitHub last year. 87,000 keys found on GitHub. Now, things have got cleaned up since then, but things are still pretty bad. I mean, I can still see a lot of credentials out there. Now, why did this happen? Because on the previous flow, half of these tools were not really designed for secrets. PowerShell, you turn on logging, it goes to the log. Humans are the worst when it comes to making mistakes. Wherever there are humans, there will be mistakes. So these mistakes happen. And it's not just security mistakes. People have forgotten to update their certificates in time, leading to outages. How many of you have seen this? Okay, very common. It's not just outages, compliance errors. So for any serious company, if you are subject to ISO, SOC, PCI compliance, you know you have to rotate your secrets periodically. You have to maintain good logs. And if you don't do that for all of your secrets, you lose your compliance status. Well, as if these things are bad enough, these are not the worst. The worst thing is, when these happen, you're not able to react quickly. No matter how good you are, you're going to make mistakes. And if you don't know where your secrets are, how they are related to each other, how to update them, you're in for a 4, 5, 6-month breach response cycle. And that's the worst. So that's where Microsoft has made a bunch of investments in Azure to make it easy for app developers to build applications and stay on top of their secrets. We have a 5-step recipe, starting with first you have to know what your secrets are. And to do that, what we've done is started to build secrets discovery into a variety of things. If you're writing code with Visual Studio, it starts now telling you right then and there, hey, that looks like a connection string. Maybe you need to take care of this. And it leads you to a service we will talk about. The other thing we have done is we actually go out proactively to GitHub looking for what looks like credentials to Azure Storage, Azure SQL, and so on. So if you're building an application on Azure, we look out for you in case any of your credentials get onto the open wide world. We look out for them. We look up, hey, which Azure Storage is this? We contact that subscriber saying, one of your credentials happens to be out there. So it's called CredScan for GitHub. So OK, so we have a variety of ways. There are many vendors out there on this floor looking for certificates who scan your endpoints and look for certificates. So you have a variety of tools, some built into Microsoft tools, some third-party, that help you find these credentials. What do you do next? Well, better than managing credentials is if you can actually get rid of the credentials. So one of the things that Azure has done is to say that if you're building an application on Azure, and you're accessing other Azure resources, you shouldn't really need connection strings and API keys and passwords. We've built in identities directly into our platforms so that when you build an application in a VM or a web app or Azure Function, which is a serverless, you have an identity already. You didn't have to provision it. You just make one call and you get a token. If you're accessing any of these resources, you can access it using that token. And so credentials are hidden from your source code. You don't have to take care of them. They're automatically rotated. They're automatically secured. All right, so that takes care of some credentials. What about the rest? What about your TLS certificates? What about your keys? What about your passwords to maybe Redis Cache, which is not going to have that? For that, we built a service called Azure Key Vault that allows you to store everything else. The idea is that the one and only manual thing that you will do with this service is the time you configure it, and everything else we want to see automated. So the idea is that we have a variety of integrations on the source side, a variety of integrations on the destination side that say, anytime you build an application, you configure your Key Vault to source secrets from this place, deliver those secrets to this particular place, and the whole thing becomes end-to-end. Even this reporting on that, monitoring of those secrets should be automated. Our idea is that everything except step number 1 should be automated. What did we get by doing this? 3 things. Number 1, we gave you a place to store all of your secrets. We encrypt it using the state-of-the-art. We store it. You got secure storage. Number 2, there are no humans in the flow of secrets. Everything got automated left to right. Fewer humans means fewer mistakes. You don't have to remember to renew them. You don't have to remember, well, did I set all the permissions right and all that? Third, there are minimal hops. So going from here to here, and from here to here, just one hop each. The more the hops, the more the mistakes. So our idea was to minimize the hops. So you got these 3 things. There are a few other things you also get. When things go wrong, your incident response becomes centralized. There is one place you have to go to manage your inventory. There's one place you have to go to look at your logs of what happened. There's one place you have to go to rotate your secrets. Digging in, this is just a blown out version of the same diagram. We have a number of sources on the left that we integrate with. You can go to a variety of certificate authorities that are pre-integrated with Key Vault. You can ask Key Vault to say, generate a key pair, go there, get a certificate, and Key Vault will keep renewing it automatically. You can integrate with a variety of Azure resources. You integrate with Thales HSMs, where you can generate a key here, BYOK it in. I'll talk about BYOK. So somehow you set up all of your credentials and keys and everything. On the right side, a number of Azure platforms are pre-integrated with Key Vault. So everything you source from here, you can say, I want that certificate going to that virtual machine. And that particular key needs to be used by Azure SQL for the purpose of encryption master keys. We just announced that feature today. And so a number of Office 365 services, Azure services, EMS services, and our partners' services are integrated with Key Vault, so such that all of these things that you auto-rotated or auto-provisioned can be used seamlessly. And a number of third-party tools are also integrated for the purpose of monitoring. Here is an example of monitoring. So this is a built-in tool in Azure called Azure Monitor. Now, this is an IT guy looking at how is my performance? Are my groups, are my teams getting the right kind of failure rates, success rates, performance, and so on? Here is another tool. This was built by a partner, Thales. It's called CCKM CipherTrust Cloud Key Manager that lets you manage keys across a variety of clouds, and they integrate with Key Vault via our API, and they give you nice scanned reports on what's happening with your keys. From a central place, you can go manage your keys, BYOK your keys, and so on. So that's secrets management. Our goal with this section was to primarily prevent mistakes by humans, mistakes by lots of tools. Let's jump ahead and talk about isolating keys. Now, once once you reduce the mistakes, the next step is, OK, now how do we keep the hackers at bay? So now, of all the things that we put in Key Vault, there's one kind of secret that is special, which is encryption keys. We can do a little bit more with that. This is back to that picture. Let's just focus on this half of it. Our idea is, if we can generate those keys, get them in a central place, manage them, rotate them, and let these guys use them in a way such that as few entities as possible can see the keys, that's victory. So how do we do that? Number one, we ensure that in this flow, master keys, any encryption keys are isolated to Key Vault. They don't actually flow out through the rest of the ecosystem. So the flow is that the key owner generates keys, uploads the keys, and sets permissions. The Key Vault service itself is, think about it as an HSM abstraction at cloud scale. We have a pool of a lot of HSMs behind. We offer extremely high SLA, 99.995 at this point. It's worldwide, so anywhere you deploy your app, within a few seconds, you can spin up your Key Vault. And all of this is tied to your Azure Active Directory. So your employees and your applications, you can manage them in your directory. You can manage the authentication in your directory. You can customize it. They get fired from your company. They lose access over here. So this is all basically trying to take the HSM hardware and trying to make it an integrated part of Azure. On the right side, you may have heard the term BYOK. The idea is that the application can use the key over the API, but cannot see the key. The key stays locked inside Key Vault. And then finally, every single transaction that you do with your key, a log is available within a few minutes so that you can analyze them and you can manage them through these tools. Inside of Key Vault, like I said, is a bunch of real hardware security modules. These are validated to level 2. There are some aspects of this, like physical assurance, that are validated to level 3. And therefore, every transaction that you do with this key, even our Key Vault service doesn't see it. It's inside those HSMs. The Key Vault service is deployed in every Azure region. It's also available in Azure Stack, which you can run on your own premises. In every region, the service is isolated by geography. So if you originate keys in, let's say, Germany Central, those keys stay locked there. The way we initialize these HSMs is also using separate master keys. So even if by mistake those keys float over to maybe East Asia or maybe the US, our HSMs there will not be able to process them. So that way we keep them as isolated as possible. Every key that you generate or import into Key Vault is backed up 3 times in the same region and 1 more time in a remote region in the same geography. This gives you extremely high disaster recovery and availability. Even if the entire West Coast gets an earthquake, your keys will be available. We keep this in the same geography. They don't actually span geographies. Our largest customers are usually subject to compliance certifications. One of our customers operates in 140 countries. And they are subject to compliance certifications in every single one of those countries. And part of that is obviously their own application, but part of that is the components that they use. We strive to ensure that Azure, the platform, is certified in as many jurisdictions as possible. We are actually, at this point, the most heavily certified cloud platform. And Key Vault inherits much of that. All right, let me jump quickly to how do we leverage all of this key management for the purpose of encryption. So when it comes to Azure, we offer you 2 kinds of encryption. One is called server-side encryption, where all the data that you upload to Azure, we encrypt on our side before we store it. The other is client-side encryption, where you encrypt before you upload to the cloud. We support both. Some of our SDKs have client-side encryption built in. And for any piece of data, you can choose to say, let Azure deal with this encryption, or let me deal with the encryption myself. Both are supported. Of course, when you encrypt, there are some features of our cloud services that will not be able to operate on them, and you have to be able to deal with that. Generally, our recommendation is for 95% of your data, the left-hand side is appropriate. And typically, in a SQL database, you might have that one column somewhere. Maybe it's the HIV status or something like that. Use client-side encryption for that, and maybe give up indexing and search on that one. So On the server-side encryption, we give you a further choice. You can just ask us to take care of key management, and we'll deal with it, no questions asked. Or you can bring in your own keys through Azure Key Vault, and everything I just talked about applies. You get your own space in the cloud. Those are HSM managed. You can rotate them. You can set permissions. You get logs. Our services, as long as you authorize them, can use that key, but cannot see that key. I'll skip over this section. There is a very nice paper on the Azure website at that URI that describes everything you need to know about encryption, which services offer encryption with customer-managed keys, which services offer client-side encryption. There's an entire table that's kept up to date all the time. Where does all of this go? So I talked about server-side encryption and client-side encryption. And there is a stark compromise over there, like I said. In this case, you get to encrypt everything on your side. You keep the data isolated from Azure, but you lose some functionality. We can do better than that. So this is where the future is headed. We demoed this at Ignite in September. This is encryption using what's called Azure Confidential Computing. So where our future goes is we are on path to using Intel SGX processors, which support this notion of enclaves, where we can actually run code, your code or our code, inside those enclaves. This diagram, let me walk through this diagram. What this is trying to show is that here is a SQL database. Here is an application. SQL's client-side SDK, ADR.NET, offers client-side encryption built in. So today, you can encrypt on the client side before you upload to SQL. And you can do some very limited queries. You can do equality-based joins. Like you can ask, is there anybody in this zip code 98052 who's age 70? You can do those queries on that data. You cannot do advanced queries like, is there anybody less than age 70? Or you cannot do addition, multiplication, things like that, because that requires us access to the decrypted data, which we don't have. You encrypted it before you upload it. With this advance, what we can do is we can actually have limited, you can grant SQL limited ability to decrypt, not on our CPU, not in the general purpose area, but inside the enclaves, where we can decrypt that data. We can process the data for these advanced operations, where you get the best of both worlds. The data stays encrypted. You encrypted it. You can ask, you can authorize us to decrypt some specific amounts of data. That decryption happens inside enclaves. So the data coming in and out is encrypted. The SQL service itself always has encrypted data at all times. So now this is in private preview right now. You can sign up for the preview and test it yourself. We are a bit away from making this generally available, but this is a sneak peek at where we are headed in terms of taking this and then applying this to other services. Encryption in transit is another topic that comes up when it comes to keys. So today, people don't even ask because all Azure services just offer encryption in transit by default. Typically, Microsoft manages those TLS certificates. But remember that diagram that I showed earlier where it said you can upload certificates to Key Vault, and there's a bunch of services pre-integrated that includes things like API management or app gateway or your VMs or web apps. All of these guys, you can supply your own certificate through Key Vault. And this term called bring your own key, we don't have a fancy term called bring your own certificate, but that's what this is really. Instead of Microsoft using its own certificate, you can upload your own certificate from whatever CA you have. You can manage those. You can auto-rotate them at your pace. And our workloads will automatically pick up and use those for the TLS. That's all I have. I'll be here for questions after this. Or if you have questions right now, feel free to ask.